Hello everyone, you are watching the Space Channel. Not so long ago, humanity began entering a new era, the era of reusable rockets. But the road to this achievement was long and filled with obstacles, both from large corporations that did not want to lose their monopolies, and from political and financial challenges. In this video, we will look at the brief history of this path, how the use of reusable rockets is changing the space industry right now, and what they will give us in the future. It is worth starting with a fairly distant history. The American struggle against NASA's monopoly began under President Reagan, who sought to open space to the private sector. At that time, NASA's policy aimed to suppress efficient private space enterprises. The fight in the United States Congress even took the form of bills intended to significantly limit NASA's authority. Specifically, H.R. 3942 and H.R. 1554. Solutions to the problems associated with NASA were found in two approaches to commercializing space. On the one hand, the agency itself was expected to take a leading role and to use the space shuttle as its primary vehicle. On the other hand, the private sector was expected to become the commercial leader in space exploration. If NASA had remained dominant in the space business, it was expected that the agency would have had to enter into agreements with commercial firms seeking to use space for their business purposes. One of the arguments used by supporters of this approach was the agency's many years of experience and significant achievements, such as the moon landing. In addition, if NASA became the center of space policy, it would allow the United States to pursue a single space policy, similar to its domestic economic policy. Another point that was often the subject of speculation was the importance of preserving NASA's position to protect the national space program of the United States. Maintaining that position would allow avoiding substantial cuts when the shuttle program began to wind down, as happened with the Apollo program. The second option was that NASA would continue its research functions, while the private sector would take the lead and become the center of commercialization. The reasons more and more people were leaning toward this option were simple. There was a general belief that the private sector should have taken responsibility for commercializing space long ago. This followed, at least, from the fact that the level of space commercialization was already relatively high at that time. Take, for example, communications satellites, which bring their owners about $2 billion per year. Satellites opened the door to the development of the launch vehicle industry, which, by the late 1980s, brought in about $3 billion per year. If control were fully transferred to the private sector, unnecessary restrictions and delays imposed by government bodies could be avoided. Of course, we would not be discussing any of this now if NASA had not once used all its power and pressure to prevent competitors from thriving. NASA's policy of preserving its monopoly was effective because the agency possessed levers of influence that left everyone else disarmed. Throughout its history, NASA consistently understated the cost of launching satellites on its own vehicles. To understand how this worked, let us consider an example. Suppose the cost of launching a satellite with NASA is $90 million, but the agency charges its clients only $40 million. Taxpayers cover the difference. As a result, any other private company whose launch of a comparable satellite costs, for example, $50 million, cannot compete with NASA because it cannot lower the price and then recoup the full amount from taxpayers. And if a private company launches rockets at a loss, it will quickly go bankrupt. In essence, a small company is pushed out of the market, even though the actual cost of its services may be much lower than NASA's. However, its clients are forced to pay more due to unfair competition from NASA. However, using tax funds to reduce the price of its services was not the only focus of NASA's policy. Those same tax funds were used, in particular, for research aimed at suppressing the agency's competitors in the private sector. While small private companies were paying taxes that were then directed toward their own destruction, NASA was developing strategies to transform the shuttles from a transport vehicle meant to support national defense and future research into a monopolistic commercial transportation system. Other dominant strategies targeted NASA's equipment and component suppliers. To keep them from working with private companies, supplier corporations were warned that if they continued supplying equipment for launching vehicles operated by private space companies, their contracts with NASA for components needed to build rockets would be at risk. NASA deliberately dragged out timelines and underpriced its services to seize the entire market, while also facilitating the shutdown of production lines for parts needed by competitors, so that ultimately, new developments would become far more expensive, and accordingly, so would their services. Beyond striking at its competitors, NASA undermined public programs and United States government initiatives for the commercialization of space, leaving on the market only costly systems held by select officials. Narrow-purpose space transports unsuitable for a variety of tasks. Even before the beginning of the 2000s, it had become clear that NASA's policy was aimed at monopolizing space. Therefore, the continued use of expendable rockets would play an essential role in the final march toward commercialization. At the same time, it became evident that government bodies should not artificially restrain the private sector, but rather support it and encourage its initiatives. This does not mean completely abandoning NASA, because the agency, together with small companies, can significantly help achieve the goal. Even so, the decisive voice should remain with American business. But where one monopoly ends, another begins, and that takes different forms. This concerns not only rockets but also satellites. Amazon and SpaceX are moving toward creating a shared monopoly by launching thousands of spacecraft into low Earth orbit to provide their users with high-speed internet, especially in regions where laying cable is not feasible. At present, Starlink owns about 5,000 satellites, and in 2020, Amazon purchased from the Federal Communications Commission, FCC, licenses for 3,000 spacecraft. The monopolization programs of these companies are intensifying an environmental crisis in Earth's orbit. We are, of course, talking about space debris, which can pose a grave threat. In essence, it has existed since the 1950s. It has accumulated for years, but now, due to the sharp overcrowding of commercial space, it can trigger a full-scale crisis about which we released a separate video. You can find the link in the description. Overall, the satellite industry is genuinely up and coming, but concentrating great power in the hands of literally two people leads to a dangerous privatization of other spheres by those same individuals. A monopoly on satellites is only a lesser evil, yet it makes it easier to create a greater evil: the complete dominance of SpaceX over space. If we trust a report by the Wall Street Journal, in 2022 the company provided 66% of flights from American launch sites. And in the first half of 2023, this figure was already 88%, with Elon Musk's company having long since extended its dominance beyond the United States. A potential lifeline for the European space sector could be a partnership agreement between Spain's PLD Space and Switzerland's WISESAT.Space. On the one hand, this could help Europe preserve its sovereignty and avoid reliance on external actors in space research. On the other hand, it could help prevent stagnation in space technology by fostering competition and, accordingly, innovation. In addition, this is about creating jobs and ensuring Europe's independence from external factors, meaning that European space programs and research will not be suspended due to outside pressures or political circumstances. Against this backdrop, over the last 10 years, humanity has begun its first, yet quite successful, steps toward the use of reusable rockets. Companies working on this together include SpaceX, Blue Origin, OM Space Rocket, and Mars Exploration Private Limited. The challenge associated with reusable rockets lies in the need to employ advanced, complex technologies for their design and construction, such as carbon fiber, selective laser melting, and even three-dimensional printing for the production of metal parts. Even now, we have known examples of reusable rockets: Falcon 9 by SpaceX, New Shepard by Blue Origin, Electron by Rocket Lab, and others. Another difficulty in designing reusable rockets is developing landing systems that must not only ensure a controlled descent and vertical touchdown, but also significantly simplify these processes. For instance, OM Space is investing in research to develop landing systems. Why is rocket landing so important? It is simple. A safe landing is the primary factor that determines a rocket's subsequent refurbishment and the possibility of reflight. Thanks to continuous development, new initiatives, and the refinement of their technologies by various companies, it has become possible to roughly forecast the development of space exploration and practical space utilization. What prospects might the development and use of reusable rockets hold for the space sector? The most excellent prospects are likely tied to a significant reduction in the cost of space missions. The introduction of reusable rockets eliminates the need to manufacture new rockets for subsequent launches, significantly reducing the cost of rocket construction. Ongoing maintenance of reusable spacecraft will not require such substantial financial outlays, making space research much easier and fully opening space for commercial and tourist purposes. In effect, launches become so inexpensive that even NASA, with its price undercutting, cannot compete with private companies. As for the commercial opening of space, reusable rockets will foster the birth of new enterprises. Frequent, inexpensive launches will promote the development of a space industry and even the expanded use of near-Earth satellites. Together with tourism, this will open new avenues for profit and for the development of the private sector. What then is the secret of success associated with the use of reusable rockets? First, reusable rockets are refurbished after missions, which significantly reduces the cost of space travel. In addition, their use prevents the formation of space debris, since rockets are no longer discarded after a single launch. The experience of using reusable rockets is no longer new. Back in 2010, SpaceX's reusable Falcon 9 rocket was launched for the first time, and since then, the company has carried out more than 20 successful rocket landings. A rocket's landing is controlled with the help of grid fins and engines. Thus, the first stage of Falcon 9 rockets is equipped with 9 Merlin engines, which allows the first stage, after separating from the second, to return to Earth and land on a landing pad. Second, there is the environmental impact of reusable rockets. During launch, thanks to these rockets' more modern engines, carbon dioxide emissions have decreased by 90% compared to their predecessors. And because missiles do not need to be replaced as often, their use poses minimal environmental risks during production and retirement from service. In addition, the amount of solid waste has been significantly reduced, since rockets no longer rely on single-use components that require disposal after the first launch. In other words, not only is the rocket's core reusable, but so are most of the components from which it is built. Thus, the use of reusable rockets will reduce environmental impacts during space exploration. The financial savings from using the new rockets are obvious. A single Falcon 9 launch costs approximately $62 million, and a Falcon Heavy launch costs approximately $90 million. Reuse reduces the cost per launch by approximately $47 million for Falcon 9 and by $55 million for Falcon Heavy. Advanced technologies enable a significant reduction in the propellant required to launch rockets, thereby substantially reducing pollution. In addition, the reduction in launch costs has opened the way to affordable space tourism, and overcoming the need to ensure each individual launch has become another advantage, significantly improving launch efficiency, increasing satellite launch accessibility, and enhancing space services. On the other hand, reusable rockets also have drawbacks, such as the need for constant maintenance. They also require more components for construction, and therefore they are significantly heavier and can carry a smaller payload into orbit. Moreover, reusable rockets are still a relatively new technology, and thus they face many technical challenges that must still be overcome. Risks can arise at all stages of a rocket's use. from launch to landing and refurbishment. Even so, these shortcomings are compensated for by the advantages. Although SpaceX's experience may be decisive in many respects, it is not the only company that specializes in the development and use of reusable rockets. For example, Rocket Lab delivers smaller satellites to lower Earth orbits using Electron rockets, whose payload capacity is about 200 to 300 kilograms, depending on the target orbit. Or we can mention the private Chinese company iSpace, which also uses reusable rockets. It specializes in delivering small and medium-sized satellites to low Earth orbit. The company is also developing the Hyperbola 2 launch vehicle, whose payload capacity will be about 2 tons. It is also worth mentioning the prospects for conducting research. Scientists can now inexpensively study the effects on microsatellites and monitor Earth's environment and events occurring on the planet. We should not forget that reusable rockets will help colonize new planets. SpaceX has long been captivated by the Interplanetary Transport System (ITS) project, which will deliver passengers to Mars using reusable rockets. Also promising is the use of space resources available on the Moon. And finally, let us sum up. The use of reusable rockets is already changing the space industry. Their use is far more economically advantageous, and with open public policy, their low cost can overcome the monopolies that have controlled the market since the beginning of the space age. Reusable rockets have drawbacks, but the advantages they offer are more than sufficient for the effective implementation of the technology. These rockets will help simplify the exploration of the planets of the solar system. They are far more environmentally friendly, and they promote the commercialization of space. That's all for now. If you liked the video, please like it and subscribe to the channel. See you next time.